Whereas glucose or carbohydrates, glucose can be metabolized anaerobically without oxygen, but also with oxygen. But to give you some numbers, if we metabolize glucose with oxygen and funnel some of those products of glucose metabolism into the mitochondria, we can get about 32 to 36 ATP from that glucose. Whereas the fatty acid, like a common fatty acid that's metabolized, palmitic acid, that name is not really important, so I don't know why I really mentioned it, but that common fatty acid can yield almost 113 ATPs. So you might be thinking, what's the catch? Why not just use fat for our energy all the time? Why would we ever use carbs? Well, as we just learned, there are some logistics involved in utilizing fat for energy. We have to pull it from the storage, get it in the bloodstream, and transport it to a muscle or potentially another cell that might utilize those fatty acids, and they could be in a different body region altogether. So there are multiple steps involved, and there's this distance concern. And yes, fats make a lot of ATP per molecule, but it just takes more time. And from an exercise perspective, it takes about 10 to 20 minutes to really ramp up your fat metabolism during exercise. And our muscles can't actually store a lot of fat, so again, we're mostly relying on that fat storage if we're going to utilize fat for energy in the muscle tissue. Whereas our muscles are great at storing glucose in the form of glycogen. Glucose doesn't make as much ATP per molecule, but it's right within the muscle, ready and available, and it's much faster to actually metabolize it and break it down. So bringing this full circle with what is actually happening inside our bodies when we lose fat. As we consistently pull those fatty acids out of the adipose cells, those cells will get smaller and smaller and smaller, which will cause the overall tissue to get thinner and thinner, contributing to that overall loss of body fat.